Hello, after a long time, I am back with one more video for class 12, that is on integration. This time I would like to explain you about what is definite integral. Um, Already I had explained you some methods of solving a indefinite integral. Now in today's video, I would like to explain you the difference between a definite integral and a indefinite integral. In As I had told you earlier also, that indefinite integral or the integration is the anti-derivative. We know what is derivative. That is the limiting value of the change in the dependent variable by the change in the independent variable. In integration, that is the reverse process. So today I would like to explain you what is the meaning of definite integral. So actually in indefinite integral we try to find out the integration in a infinite interval, whether any interval is not fixed, but in indefinite integral the integration is done within a closed interval. We try to find out what is the integration within a given interval. So in order to understand the concept properly, let us go through the concept very clearly, for which let us see what is the definition of definite integral and how it is solved, the working rule through some examples. I hope you all are enjoying the video. In order to share the video, please don't forget to click on the share button and ask your friends to subscribe my channel so that more and more friends of yours can benefit through my video. So let us proceed for the next section of the video, that is the definition of definite integral and some examples. Concept of definite integral, let us understand what is the definition. If phi x is the integration of the continuous function fx dx and fx is defined or fx is continuous in the interval a to b or ab, closed interval ab, then the definite integral is denoted by a to b fx dx. This is how we denote a definite integral, and its value is phi of b minus phi of a. That means whatever is the integration of fx, we find out the value of the integration at the upper limit and subtract it with the value at its lower limit. That means this a is the lower limit and b is the upper limit. These numbers a and b are the lower limit and the upper limit. Now to add to this concept, I would like to tell you that in indefinite integration, the integration which we have studied without this limits, upper or lower limit, there we used to add an arbitrary constant c, but here we are not supposed to add it, because suppose the integration of fx dx is as I told phi x plus c. Then if I add here a and b as a limits of lower and upper, then here also we write a and b. Then according to the definition which I told, it should be phi of b plus c minus phi of a plus c. So this c gets cancelled, so finally we get phi b minus phi a. So uh, this is the reason why we don't write c as the arbitrary constant which we used to write in case of indefinite integers. Anyway, let us understand how to solve or how to find out the value of an definite integration. Very simple question I have taken for your understanding. And integration of 1 by 1 plus x square from -1 to +1. We know the integration of 1 by 1 plus x square is tan inverse x. Now we are supposed to put the values -1 to +1. They are the lower limit and the upper limit. As I have told you, we are supposed to put the first upper limit, that is tan inverse 1 minus tan inverse -1. So tan inverse 1 is pi by 4 and this is minus of minus pi by 4. That is equal to pi by 4 plus pi by 4, that is pi by 2. So this is how we integrate. Let us take another example. I suppose you all are understanding how to solve a definite integration. Now 0 to pi by 2 under root 1 plus sin x. So this is, let us simplify, this is under root sin x by 2 plus cos x by 2 whole square. So this is finally equal to integration of 0 to pi by 2 sin x by 2 plus cos x by 2 dx. This is cos minus cos x by 2 by 1 by 2 plus sin x by 2 by 1 by 2, 0 to pi by 2. So 2 is common, minus cos x by 2 plus sin x by 2, 0 to pi by 2. So we get 2 minus cos pi by 4 plus sin pi by 4. Minus cos 0, minus cos 0 plus sin 0. This is 2. This will be 1 by root 2 minus 1 by root 2 plus 1 by root 2, that is 0. Minus cos 0 is 1 plus sin 0 is 0. This is minus cos 0. So this becomes 2 into 1. This is 0. This is plus 1. So 2 is the answer. So finally the integration of under root 1 plus sin x in between the interval 0 to pi by 2 is 2. Another example. Now this time the example which I have selected is, here we are supposed to use substitution. Here, in order to solve this indefinite integration, suppose we neglect this 0 to 1, we know that we have to substitute here x square equal to t. That is dx, x dx, we get 1 by 2 dt. So putting the values. Now let me tell you, when we are solving a definite integration with the help of substitution, we are changing the variable. So we are supposed to change we are supposed to check how the function behaves when the variables are changed. That is, when x equal to 0, t is also 0 because we put 0 here, then t also becomes 0, and when x is 1, that time t is also 1. So the limits remain same, but we are supposed to check this, and accordingly we integrate. So 0 to 1, x dx is half dt, and in place of e to the power x square we write e to the power t. So we get 1 by 2. Integration of e to the power t is e to the power t 0 to 1, or half e to the power 1 minus e to the power 0. Here we know we have to substitute here sin x equal to t. Then cos x dx is dt. So when x is 0, according to the substitution, we put x 0 here in sin x, then t is also 0. When x is pi by 2, sin pi by 2 is 1, so t becomes 1. So instead of writing 0 to pi by 2, we are supposed to write 0 to 1. Instead of cos x dx, we are supposed to write dt and 1 plus t square. So this is tan inverse t, because integration of 1 by 1 plus t square is tan inverse t 0 to 1. So tan inverse 1 minus tan inverse 0. So this is tan inverse 1 is pi by 4, 45, minus tan inverse 0 is 0, that is pi by 4 is the answer. So this is how we understood how to find out the definite integration of a function when it is by the method of substitution. So we should remember that when we are doing the integration with the method of substitution, we are supposed to check how the new variable behaves with the function when the limits are put in the place of old variable, and how the new variable behaves. So thank you. I suppose you have understood. Any comments you have, any doubts you have, you can obviously write in the comment section. We shall meet again, where I shall explain you what is the properties of definite integration and how to use the properties of definite integration to solve questions in an easier way. Thank you and see you again. Bye bye.